Alright, this is Unit 6, Lesson 2 of our Pre-Calc 12 class. Unit 6 is called Conics. Lesson 2 is still talking about our first example of a conic, which is the circle. It's called writing equations of circles. So this is a continuation, or a part 2 of the last lesson. So now we're going to look at, okay, if I have the center and the radius of a circle, how do I write the equation? Basically working backwards from last lesson. So here again is our equation for a circle. HK being the x and y coordinates of the center of the circle, and r being the length of the radius of the circle. So sometimes it can be really easy to calculate the radius of a circle, or basically count if our center of our circle and a point on the circle had the same y value, so this horizontal, and the x values are nice whole numbers. You can just count the squares and see how wide the radius is. More often than not, what's going to happen is we are going to have to use a calculation to find the radius. So given any coordinate of a point on the graph, the distance between two lines is Pythagorean theorem solved for the radius, also called the distance formula. So if a center of my circle is x1, y1, and any point on our graph is x2, y2, we can calculate the square root of the change in x squared plus the change in y squared. So this triangle is called a delta. It just means change in x, change in y. Change in x squared is how much the y is changing by. So x2 minus x1, absolute value, because again we don't care about if it's negative, we just want to know how long this side of a triangle is. The change in y value, how long this side of the triangle is the absolute value of y2 minus y1. And you can go x2 minus x1 or x1 minus x2. As long as you're consistent with both the x and the y, it doesn't make a difference. So anyways, this is just a nice long way of saying how long is this x piece, how tall is this y piece. We square those and square root it, and that gives us the radius. So that's our setup there. It's called the distance formula. If you want to Google it and see a better explanation, distance formula. Here's an example of how it works. So if I give you the center of a circle and a point on the circle, h and k are right there. 3 and 9 are h and k. So we can plug those in. X minus 3 squared plus y minus 9 squared. Now the radius is going to be the square root of 3 minus 8, the x values, squared. And we're going to add the absolute value of 9 minus negative 3 squared. So 3 minus 8 is negative 5, 9 minus negative 3 is 12. So the absolute value of negative 5 squared is 25, and the absolute value of 12 squared is 144. Add those together, 169, and the square root of 169 is 13. So the radius is 13, or radius squared would put us back to 169. So here's our equation for this circle right here. Alright, another example. So again, h and k are given. We plug those into our formula. So we'll have x squared, and we'll have, since k is negative 7, we'll have y minus negative 7, or y plus 7 squared. We have a radical in here. It looks more intimidating at first, but really it's no different. We calculate the x minus x would be square root of 44 minus 0, absolute value and square it. The y's would be y2 minus y1, so negative 2 minus negative 7 would be 5, so absolute value and square it. Absolute value of square root of 44 squared is 44. See? Square root went away. Not too bad. Absolute value of 5 squared is 25. Add those together, we get square root of 69. And so the radius is the square root of 69. So the radius squared for our equation, the radius squared is the square root of 69 squared, which is just 69. So here's our final equation. Because our x plus 0 is there, I can just write that as x squared. Y minus negative 7 is y plus 7 squared, and then equals 69. Okay, what if I give you the graph? So instead of giving you the center and a point, just give you a graph. Well, you can find the center. It's right here, -1, +1. So -1's our h value, +1's our k value. So we'll have x minus -1 squared and y minus 1 squared, or x plus 1, because minus and negative is positive. And we'll have x plus 1 squared plus y minus 1 squared. The radius, if I go straight across, my hope would be that we hit exactly on an x value, but we don't. This is, if I go straight horizontally across, we're like a little bit above 6. And so I can't really estimate that accurately. So what we're going to do is we're going to use distance formula. I do notice that the point 1, -6 is on our circle, so I'm going to type in 1 and -6 for our x2 and y2. So we'll have 1 minus -1. We'll have negative, well, how do I do this? 1 minus -6, y1 minus y2. We have -1 minus 1, or our x1 minus x2, and that's all up in here. And we do our calculations, we get that radius is the square root of 53. And so in our equation, x plus 1 squared plus y minus 1 squared equals the square root of 53 squared, which is just 53. Alright, so basically now that we know how to calculate radius if it's a diagonal on a circle. We know how to take the center and the radius and plug it into our standard form of a circle equation and write a simplified equation for the circle. And that's dope. That's dope.